how to use trigonometry in the Cartesian plane. So it's using x and y coordinates. So far we have found trig ratios for angles that are smaller than 90 degrees. However, we can find the ratio for any angle, even if it's bigger than 90 degrees, if we look at the Cartesian plane. So the first thing we have to know is what a standard position is for an angle. So standard position angles have their vertex at the origin, and then they have one ray on the positive x-axis. And then the other ray is what we call the terminal ray. So here's our initial ray, which is going to be on the positive x-axis. And then here's our terminal ray. And then we call that angle between the initial ray and the terminal ray, we call that theta. And that little symbol is what theta represents. And then, of course, 90 degrees would be up here in the positive y-axis. Then we have 180, which is going towards the negative x-axis. We have 270, which is the negative y-axis. And then we have 360, which is also where 0 is. So we will be using reference angles to figure out our trig ratios. And you have to remember that no matter what quadrant you're in, either 1, 2, 3, or 4, all standard position angles have what's called a reference angle. And every reference angle is going to be less than or equal to 90 degrees. So you make a reference triangle by drawing the angle, then drawing a vertical line from the terminal ray to the x-axis. And then the angle at the origin is the reference angle. So suppose an angle is x. The reference angles can be found using these formulas. If it's in the first quadrant, it's just going to be x. If your angle is in the second quadrant, you're going to do 180 minus x. If it's in the third quadrant, you're going to do x minus 180. And if you're in the fourth quadrant, you're going to do 360 minus x. And that's how you're going to find your reference angles. So let's try one. Let's try 220. So 220 is in the third quadrant, which means that you would do 220 minus 180. So 220 minus 180 gives us 40. So the reference angle is 40. Okay, now we'll do a reference angle for 310. So since 310 is in the fourth quadrant, we would do 360 minus 310, which gives us a reference angle of 50. For a reference angle of 135, that would be in the second quadrant. So we would do 180 minus 35, and that gives us 45. A reference angle for 300. 300 is in the fourth quadrant, which means we would do 360 minus 300, which is 60. So you'll notice that 60 and 45 are special angles, which means, yes, they are going to have our special trig ratios. Here's a reverse question. What second quadrant angle has a reference angle of 60? So remember, in the second quadrant, you did 180 minus the angle. So 180 minus what gives us 60, and that would be 120. Let's do another. What fourth quadrant angle has a reference angle of 45? So remember, at the fourth quadrant, you would do 360 minus the angle to get 45. So 360 minus 315 is 45. Okay, so if we are looking on the Cartesian plane, you'll notice that our triangles look like this. We have an x, and then we have y, and then we have r, which is the radius if you were to look at a unit circle. Okay, so the x, you'll notice here, is the adjacent to theta. The y, which is the vertical distance, is opposite. So the SOHCAHTOA, the opposite and the adjacent, opposite is y and adjacent is x. So if you're given a point which has an x and y coordinate, you can figure out a trig ratio using x for adjacent and y for opposite. And then r, radius, so this is a right triangle, so your r is going to be found using Pythagorean theorem. So x squared plus y squared equals r squared. So you can solve for r, which is your hypotenuse. So again, sine, which we learned as opposite of hypotenuse. Remember, opposite is y and hypotenuse is your radius. So sine is really y over r. Cosine is x over r. And tangent is y over x. So those are our trig ratios for the Cartesian plane. And then we have our reciprocal trig ratios. So cosecant, which is the reciprocal of sine, so you would flip sine. Sine is usually y over r, so the cosecant would be r over y. And then secant, which is the reciprocal of cosine, would be r over x. And cotangent, which is the reciprocal of tangent, would be x over y. So let's find the sine, cosine, and tangent of an angle passing through the point 3, 4. So remember, 3, 4 is a coordinate where x is 3 and y is 4, which means that it's lying in the first quadrant. And to solve for the radius, we can do 3 squared plus 4 squared equals r squared, which would mean that r would be equal to 5. Now we know what x, y, and r are. We can do our sine, cosine, and tangent. So sine is y over r, so it would be 4 over 5. Cosine is x over r, so it would be 3 over 5. And tangent is y over x, so it would be 4 over 3. Now, I mentioned that point was going to be in the first quadrant. Now, if your angle is not in the first quadrant, there is an easy way to remember if you're going to be positive or negative. So if you're looking, so these are the quadrants. So here's quadrant 1, everything is positive. And quadrant 2, your sine is positive, but your cosine is negative, and your tangent's negative. So if you're thinking about it, if you're in quadrant 2, your sine, which is your y, is positive, but your x is negative. So sine is positive and cosine's negative. And then tangent, which uses y and x, we have a positive and a negative, that means our tangent will be negative. Quadrant 3, your y and your x are both negative. So your sine will be negative, your cosine will be negative, but your tangent, since we have both negatives, remember 2 negatives make a positive. So your tangent will be positive in quadrant 3. And then in quadrant 4, your y's are negative, which means that sine is negative. However, your x's are positive, so your cosine will be positive. And since you have a negative and a positive, your tangent in quadrant 4 will be negative. So if we want to find the sine, cosine, and tangent of the angle passing through the point 3, 0, it might be a little bit more difficult because you can't make a triangle to find this one. So what you would have to do, since you can't make a triangle because there's no height, it's just 3, 0, so it's on the x-axis. But if you think about it, here's 3, 0 right over here. So this is essentially saying 0 degrees. So you still can find sine, cosine, tangent. X is equal to 3, y is equal to 0, which means your radius is equal to 3 because x squared plus y squared has to equal r squared. So that means, and we said that that represents 0 degrees. So here is a nice chart to help you remember the sine, cosine, and tangent for the angles that are on the axes. So 0 and 360, which means the beginning and the end. So your sine will be 0, cosine will be 1, and tangent will be 0. Now 90 degrees, which is that 90-degree angle, so going up towards the positive y-axis, sine is going to be 1, cosine will be 0. However, tangent is undefined because it makes a vertical line. 180, which is going to the negative x-axis, sine is 0, cosine is -1, and tangent is 0. And then 270, which is going negative y, sine is -1, cosine 0, and then tangent will be undefined. Alright, so sine 135. So first we can figure out what is our reference angle. So 135 is in the second quadrant, so you'll do 180 minus 35, which means our reference angle is 45. So now that we know our reference angle is 45, we can use our special 45-45 triangle to figure out what sine is. So using 45-45 triangle, we know it's 1 square root of 2, which means that sine would be the square root of 2 over 2, or it's actually probably 1 over the square root of 2. However, you have to rationalize the denominator, which is how you got the square root of 2 over 2. However, since we are in the second quadrant, we now have to think, is our answer positive or negative? So since we are looking at the sine and we are in the second quadrant, our answer will be positive. Let's look at tangent of 330. So first, we look at what is the reference angle. It's in the fourth quadrant, so we do 360 minus 330, which means our reference angle is 30, which means we can use our special triangle, the 30-60 triangle. And using the 30-60 triangle, we know that our trig ratio is going to be the square root of 3 over 3. And then we have to figure, since we are doing tangent and we're in the fourth quadrant, that means that our answer is going to be negative. So this is what you need to remember when doing trig ratios in the Cartesian plane. Remember your 6 basic trig ratios, so sine, cosine, tangent, cosecant, secant, and cotangent. You need to remember your special triangles, so your 45-45 and your 30-60. You need to remember sine, cosine, and tangent for all your special angles. And then you need to remember which ratios are positive and negative in each quadrant.